Now we will talk about what all the layers present in a CNN network will perform. So coming into the first thing, the convolutional layer. So this layer is the first layer that is used to extract the various features from the input images. And the output is termed as the feature map, which gives us information about the image, such as the corners and edges. So the convolutional layer in CNN passes the result from the images and and gets the features from those images, and then it sends the result to the next layer once applying the convolution operation. Then it will send it to the pooling layer. So pooling layer. So what does this pooling layers do? The primary aim of this layer is to decrease the size of the convolved feature map to reduce the computational costs. So this is performed by decreasing the connections between the layers and independently operating on the future maps. So, uh, so in this, after this, the output is sent into the next layer, which is the flattening layer. So in flattening layer, what happens is it's it flattens the output. Sorry, it flattens the input, uh, which is it flattens the input that it got, and which is nothing but the output that is sent by the pooling layer 2. So after the data gets flattened, then it goes to the fully connected neural network, right? So what does this fully connected neural network does is it consists of weights and biases along with all these neurons, and which are used to connect the neurons between the two different layers. These layers are usually placed between the output layer and also from the from the last layers of the CNN architecture. So after the input is sent to the fully connected layer, then we will have the dropout layer, right? So what does this dropout layer do is uh, uh, so basically it makes the model to not become overfitting. So, uh, so what does this reduce is it reduces the size of the model. So maybe it can pass any percentage of around 100, and then those percentage of nodes are randomly dropped out. So due to which the spatial size may be reduced, because of which the model performance will be also very good. And after that we'll have the activation functions. So in these activation functions, yeah, it is used to learn and approximate any kind of continuous and if there are any complex relationships. So after that, we'll have the output layer where we will get the output, whether it's classification or anything. So so this is the information about all those layers and what all they perform. Now, after the architecture of the CNN network is done, then what we should do is we should design the model. So, so the design will be done from by the architecture. So now here we can see that we are using uh, two convolutional layers, two pooling layers, one flattening layer, one fully connected layer, and one dropout layer, and also one output layer. So with all these including, we will design the model. So here we can see that our convolutional layer shape is 4D shape, and our input data size is 32 by 32, which is nothing but height and width. So we can see the depth as 3 in input channel. That means the the input which we are sending, like any image, so it has the colors of RGB. So like if the input images which we have like in a single color, then the depth will be not 3, but it will be 1. Then here we can also see the window size. Window size we have, the window size which we are taking is it's 5 by 5. Then if you are coming to the strides, we are using the stride as 1. So and the padding is equal to same. Padding is same means we are not changing anything, or we are not giving anything. So the activation function which we are using is ReLU layer. So this is the design for convolutional layer, and then ReLU layer 1. So here we can see the input shape as 32 by 32 by 32. So it's nothing but the output which has been sent by convolutional layer 1. And you can see the input shape is same as the output shape in the ReLU layer 1. So uh, so this says that it does only extract the features, but it does not change the shape. So the so here you can see the pooling layer 1. So here in pooling layer 1, we are using the method as maximum pooling, and then the stride as 2. So after that, here uh, we can see the output shape as 16 by 16 by 32. So what does it does means, when we are processing our data from the convolutional layer 1 to LU layer 1 to pooling layer 1. So what happens means our height and width will be going on reducing, and the output size will be going on increasing. So that is the reason here we can see the height and width is 16 by 16, and the output, or the depth of the output channels, it is 32. So here you can so this is the design for convolutional layer 2. So here we can see the depth as here we can see the input shape depth as 32, and the depth of output is 64. So we can see that the output nodes or neurons uh, are doubled, and the input shape will be the same for the convolutional layer 2, which is the output of convolutional layer 1, uh, and the output shape will also say same in the ReLU layer. Then the same max pooling and everything for pooling layer 2, and then after the pooling layer 2, now the output is going to fully connected layer, and here we can see the input it is getting as 8 by 8 by 64, and the output nodes which we want to be is around 1024. So here you can see the design for the dropout layer, and then it is connected final output layer. So this is the code that we are using to test the CIFAR10 model. Here first we are loading the data, and then after the loading the data, we will first define the functions that will support us to build the to build train and test the CNN model. So here first we are building a function which will define the initial variable with values to initial weights, and then we are creating a function for initializing the bias, and then we are creating a function of a convolutional layer and computing the dot product, which is the multiplication of the weights and bias, and the other function is ReLU layer and computing dot product adding bias. So this is like after multiplying the initial weights and bias, we will add that to the ReLU layer. So this is the function, and then this is the function for max pool, which is like creating the pool size, and then it is a function for mental layer. So here we can see that we are using the TensorFlow as a library for building the convolutional neural network. And these are the code for the flattening the data and creating the fully connected layer. So here we are using softmax cross entropy loss and loss function, and then the learning rate is around 0.001, which we are using for this code. After that, we are creating a variable named CNN train, which is optimizes the cross entropy mean, and then the steps which we are which we want to initialize, or the number of steps which we want for the data to get trained is 5,000. And after running all those steps, we can see that the accuracy, the model has been started as 10 percentage on the step 0, and then suddenly it got reached 37 percentage on step 100. So in this way, we can see that the accuracy has been increasing on every step. This is that on every step the data has been getting trained, and then it started giving more accuracy. From this image we can see that uh, uh, the accuracy is around 68% on the final step. And also we can see the accuracy of step 4,700 as 6,000 as 67 percentage, and then accuracy of 40 and 4,800 step is 65 percentage. So this says that the accuracy has been plunging and remains almost the same, even we are having two convolutional layers. So this says that even two convolutional layers are also not enough to capture all the features in the data of the CIFAR 10 dataset.